Great day, learners! Welcome to another fun and interesting math learning experience. What are you waiting for? Ready your pen and paper, your self-learning modules, or your compendium of notes, and together, let's rock math. This week, we will learn about the equation of a line given a slope and y-intercept, given the slope and the point, and given 2 points. With that, let's start off with the equation of a line given the slope and y-intercept. If the graph of a linear equation has a slope m and y-intercept b, then its equation is y is equal to mx plus b, or what we call the slope-intercept form. Let's study these examples. Let's find the equation of the linear equation in slope-intercept form and standard form given its slope m and y-intercept b. Let's have letter A. The given slope is equal to 3 and the given b equals 1. Our first step is to substitute the given m and b in the slope-intercept form. Remember, the slope-intercept form is y equals mx plus b. Since m and b are already given, this becomes y equals 3x plus 1. Our second step is to transform it into standard form. We have y equals 3x plus 1. In order to transform this into standard form, we have to put all the terms with variables together and the constant on the other side of the equal sign. In this case, let's put y with 3x. Through addition property of equality, let's subtract y on both sides of the equation. So we have y minus y equals 3x minus y plus 1. We simplify, the result will become 0 equals 3x minus y plus 1. Next, let's put the constant or 1 on the other side of the equation. Through addition property of equality, we subtract 1 on both sides of the equation. We have 0 minus 1 equals 3x minus y plus 1 minus 1. We simplify, we have negative 1 equals 3x minus y, or 3x minus y equals negative 1. Let's have letter B. The given m equals negative 2 and the given b equals negative 5. Again, our first step is to substitute the given m and b in the slope-intercept form. Our slope-intercept form is y equals mx plus b. The given m equals negative 2, the given b equals negative 5. We substitute, this becomes y equals negative 2x minus 5. Our second step is to transform into standard form. To transform y equals negative 2x minus 5, let's put y and negative 2x together. Through addition property of equality, we add negative y on both sides of the equation. We have y minus y equals negative 2x minus y minus 5. We simplify, this becomes 0 is equal to negative 2x minus y minus 5. Now, let's put the constant on the other side of the equation. We add positive 5 on both sides of the equation. We have 0 plus 5 equals negative 2x minus y minus 5 plus 5. This becomes 5 equals negative 2x minus y, or 2x plus y equals negative 5. Now, let's have letter C. The given m equals negative 2 and the given b equals 2/3. Again, our first step is to substitute the given m and b in the slope-intercept form. Our slope-intercept form is equal to y equals mx plus b. The given m equals negative 2, the given b equals 2/3. We substitute, this becomes y equals negative 2x plus 2/3. Our second step is to transform into standard form. If you can notice y equals negative 2x plus 2/3, we have a fraction. In order to remove the fraction, we have to multiply both sides of the equation by the denominator, which is equal to 3. So we have 3y equals 3 times the quantity negative 2x plus 2/3. We simplify, this becomes 3y equals negative 6x plus 2. Now let's put 3y on the other side of the equation. Through addition property of equality, we add negative 3y on both sides of the equation. We have 3y minus 3y equals negative 6x minus 3y plus 2. We simplify, this becomes 0 equals negative 6x minus 3y plus 2. Now let's put the constant on the other side of the equation. And then to do that, let's add negative 2 on both sides of the equation. We have 0 minus 2 equals negative 6x minus 3y plus 2 minus 2. We simplify, this becomes negative 2 equals negative 6x minus 3y, or 6x plus 3y equals 2. Now let's have the equation of a line given the slope and the point. If the graph of a linear equation has a slope m and passes through the coordinates x sub 1 and y sub 1, then its equation is y minus y sub 1 equals m times the quantity x minus x sub 1, or what we call the point-slope form. Let's study these examples. Let's write the equation of the linear equation in point-slope form and in standard form, whose graph passes through the given point xy and has the given slope m. Let's have letter A. Our first step is to substitute the values to the point-slope form. Our given, we have x sub 1 is equal to 2, y sub 1 is equal to 4, and the given m is equal to 3. The point-slope form is y minus y sub 1 is equal to m times x minus x sub 1. We simply substitute, this becomes y minus 4 is equal to 3 times the quantity x minus 2. Our second step is to transform the resulting equation in the required forms. We have y minus 4 equals 3 times x minus 2. We distribute 3, this becomes y minus 4 equals 3x minus 6. Now, we put negative 4 on the right side of the equation, and this becomes y equals 3x minus 6 plus 4, or if we further simplify, this becomes y equals 3x minus 2, or in a standard form, this becomes 3x minus y equals 2. This time, let's have letter B. Our first step is to substitute the values to the point-slope form. Our given is x sub 1 equals negative 2, y sub 1 equals 3, and the given slope is 1. Now our point-slope form is y minus y1 is equal to m times x minus x sub 1. We simply substitute, this becomes y minus 3 equals 3 times x minus negative 2. Our next step is to transform the resulting equation in the required forms. We have y minus 3 equals 3 times x plus 2. This becomes positive 2 since we distribute the negative sign from the earlier equation. Now, let's distribute 3. So this becomes y minus 3 equals 3x plus 6. Let's put negative 3 on the right side of the equation. This becomes y equals 3x plus 6 plus 3. We simplify, this becomes y equals 3x plus 9, or in standard form, this becomes 3x minus y equals negative 9. This time, let's have letter C. Again, our first step is to substitute the values to the point-slope form. Our given, we have x sub 1 equals 3, y sub 1 equals negative 2, and the given slope is negative 1/3. Now, our point slope form is y minus y sub 1 is equal to m times x minus x sub 1. We simply substitute, we get y minus negative 2 is equal to negative 1/3 times x minus 3. We simplify y minus negative 2, it becomes y plus 2 is equal to negative 1/3 times x minus 3. Our second step is to transform the resulting equation in the required forms. As you can notice, the given slope is a fraction. In order to remove that, we multiply both sides of the equation by the denominator, which is equal to 3. Thus, we get 3 times the quantity y plus 2 is equal to 3 times negative 1/3 times the quantity x minus 3. We simplify the left side of the equation. We distribute 3, so it becomes 3y plus 6. On the right side, we cancel 3, so it will be just negative 1 times the quantity x minus 3. Now, let's distribute negative 1 on the right side of the equation. We get 3y plus 6 is equal to negative x plus 3. Let's put 6 on the other side of the equation. We get 3y is equal to negative x plus 3 minus 6. We further simplify, this becomes 3y is equal to negative x minus 3. To get the slope-intercept form of this equation, we divide both sides of the equation by 3. Therefore, we get y equals negative x over 3 minus 1. Or if we transform this into its standard form, this becomes x. 3y is equal to negative 3. Earlier, we have learned about the equation of a line, given the slope and the y-intercept, and given the slope and the point. This time, let's learn about the equation of a line given 2 points. If the graph of a linear equation passes through the points x sub 1, y sub 1, and x sub 2, y sub 2, then its equation is y minus y1 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1, or what we call the 2-point form. Let's have these examples. We write the equation of the linear equation in slope-intercept form and in standard form whose graph passes through the given pair of points. Let's have example A. We have here the given pair of points 5, 4, and 3, 0. Our first step is to determine the values of x sub 1, y sub 1, x sub 2, and y sub 2. In this case, the value of x sub 1 is equal to 5, y sub 1 equals 4, x sub 2 equals 3, and y sub 2 equals 0. We simply substitute these values in the 2-point form, which is y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times the quantity x minus x sub 1. The result will become y minus 4 equals 0 minus 4 over 3 minus 5 times x minus 5. Let us simplify. This becomes y minus 4 equals 0 minus 4 over 3 minus 5 becomes negative 4 over negative 2 times x minus 5. And then we have y minus 4 is equal to negative 4 over negative 2 becomes just positive 2 times x minus 5. If you can notice, we can still further simplify the right side of the equation by distributing 2. So it becomes y minus 4 equals 2 times x becomes 2x, and 2 times negative 5 becomes negative 10. And this time, let's put negative 4 on the right side of the equation. This becomes y equals 2x minus 10 plus 4. We further simplify, this becomes y equals 2x minus 6 or if we transform this into its standard form, this becomes 2x minus y is equal to 6. Let's have another one. We have here another pair of points, negative 4, 3, and 5, negative 2. First, we determine the values of x sub 1, y sub 1, x sub 2, and y sub 2. In this case, we have x sub 1 equals negative 4, y sub 1 equals 3, x sub 2 equals 5, and y sub 2 equals negative 2. And then we simply substitute this to the 2-point form. And so we get y minus 3 equals negative 2 minus 3 over 5 minus negative 4 times x minus negative 4. We simplify. On the left side of the equation, we have y minus 3. Now, let's simplify the right side of the equation. Negative 2 minus 3 equals negative 5. Over 5 minus negative 4 becomes positive 9. Times x minus negative 4 becomes x plus 4. If you can notice, negative 5 is not divisible by 9. Therefore, there exists a fraction. In order to remove that, let's multiply both sides of the equation by the denominator, which is equal to 9. And we get 9 times y minus 3 equals 9 times negative 5 over 9 times x plus 4. We simplify. We distribute 9 to the left side of the equation. So 9 times y becomes 9y, 9 minus 3 becomes negative 27. Now let's go to the right side of the equation. We can cancel 9. And so we are left with negative 5 times x plus 4. We can still simplify the right side of the equation by distributing negative 5. We get 9y minus 27 equals negative 5 times x becomes negative 5x, and negative 5 times positive 4 equals negative 20. And then, we put negative 27 on the right side of the equation. We get 9y equals negative 5x minus 20 plus 27. We add similar terms, it becomes 9y equals negative 5x plus 7. In order to get the slope-intercept form of this equation, we divide both sides of the equation by 9. And so we get y equals negative 5 over 9x plus 7 over 9, or in standard form, it will become 5x plus 9y equals 7. That's it for the equation of a line. How was it? Did you understand? I hope you did. But before we end, let's have a quick recap. In this session, we have learned about the slope-intercept form, the point-slope form, and the two-point form. If the linear equation has a given slope m and y-intercept b, we use the equation y equals mx plus b, or the slope-intercept form. If the linear equation has a given slope m and passes through points x sub 1 and y sub 1, we use the equation y minus y sub 1 equals m times x minus x sub 1, or the point-slope form. And lastly, if the linear equation passes through the points x sub 1, y sub 1, and x sub 2, y sub 2, we use the equation y minus y sub 1 equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1, or the two-point form. Now, let's wrap up this session through an evaluation. Ready your pen and paper, and let's solve together. Given the following, Write the equation of the linear equation in slope-intercept form and in standard form. I will give you 10 seconds to answer each question. If it's not enough, you are free to pause this video and solve it at your own pace before you reveal the answer. Are you ready? Let us start off with number 1. That's it for the equation of a line. How many items did you get correctly? Whatever your score is, I hope that you have learned a lot from this session. Keep practicing and keep improving. This has been Teacher Mark saying that math matters. Till next time!